15.3 is on geometric sequences. And what's different about geometric sequences versus arithmetic is that geometric, you're multiplying by something every single time to get to the next term number. Now, sometimes it'll look like it's dividing, but for the most part, when you're writing these equations, even if it's dividing, we want to figure out what it is in terms of multiplication. If you end up dividing, I want you to treat the common ratio as a fraction, meaning this. Let's say I have a simple 8, 4, 2, 1, 1/2, 1/4, ... You can see what's happening here, I hope. What is the pattern? The pattern is dividing by 2. Your common ratio isn't divided by 2. Your R for something like this you would treat as a fraction. You're multiplying 8 by 1/2. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1, and so on. Treat anything that's dividing as something with multiplication as a fraction for the common ratio. Now, I like geometric sequences, and I'm very biased. I'm very, I like the kind of math that can be applied to real life. And something that I have a personal vendetta against, or something that I do not like, is that I have to teach you a lot of different types of math that are out there that are good foundations for future math, but sometimes I get to something like this and I go, yes, finally something that they can use in real life. This kind of equation, this kind of math, this equation that is right here is used to figure out interest rates. It's used to figure out how much money you're going to owe on your house, on how much money you're going to owe on your car, how much you're going to spend on your student loan, things in real life. The kind of math that actually matters post high school. This is the math. A lot of you, and the worksheets that we give you doesn't really use this kind of math, though, in the way that you're going to use it in real life. So I wish that we could teach a class that shows you how personal finance and money deals with this kind of stuff, because this is where it's used in real life. And so I need to mention that, because if I didn't, I would not be like telling you there's a big picture when it comes to mathematics and the rest of your life. I wish I could teach my father some of this stuff. And because my father does not make the best financial decisions based off of interest, and if he knew this formula or understood the formula, then I think he would make better decisions as far as that goes. Okay? So with that being said, what we do for geometric sequences is we have this first term, or your principal, your starting value. This is where the principal would come into play. Your interest rate, or the rate that you're multiplying by your common ratio to the n minus 1 power. This is in the exponent, by the way. These are what those things stand for, and we're going to do the same kind of problems that we did in the previous section, only geometrically. So, the rest of these are examples that you can do with me. If you want to start on your 15.3 blank sheet of paper for your homework, feel free to do so. Number 6, determine whether the sequence is geometric. If so, find the common ratio. You have to decide, are you multiplying by the same amount every single time to get to the next number? Here's how I do it. If it is geometric, then I'm going to multiply this by something to get there. So sometimes I'll just take this number and I divide by this number. And I go, oh, it's 3/10. 0.3 or 3/10. Let's see if that works. 100 times 3/10. 10 goes into there one time. 10 is 30. 30 times 3/10 is 90/10 or 9. Okay? 9 times 3/10 is 27/10 or 2.7. Is this geometric? My answer is yes. What is the common ratio? What am I multiplying by every time to get to the next one? Either 3/10 or 0.3. There's my answer. Do I prefer whether it's a fraction or a decimal? No. It's just easier. I would accept either one. Number 12. Write an explicit rule for each sequence. Then find the 10th term of the geometric sequence. Calculators are a must when we get to this. And so I am going to use this formula. And the way I memorize this is because I use it so often when it comes to money. I hate to tell you that, but it's true. I think of A of 1 as your starting or your principal or how much you begin with. I think of R as whatever your rate is, and then N minus 1. So let's go down here. Write an explicit rule for each sequence. Then find the 10th term. So I know that the formula is for geometric A of 1 times whatever my rate is to the N minus 1 power. What is my first term's value in this particular sequence? I hope you know it's 1/4. What are you multiplying by to go from here to here? What are you multiplying by to go from here to here? You're multiplying by something. If you know what you're multiplying by, tell the person you're sitting next to. That goes in parentheses. N minus 1 power. This is the answer for the explicit rule. This can be used to find any term number. I can use it to find the first term number. Let's check to see. If I plug in the number 1, I should get 1/4. 1 minus 1 is 0. 2 to the 0 power is 1 times 1/4. Guess what? I get the first term number. Let's plug in the number 2. 2 minus 1 is 1. 2 to the first is 2. 2 times a 4th is 1/2. You plug in the number 3. 3 minus 1 is 2. 2 squared is 4. 4 times 1/4 is 1. It works. The reason why I show that to you is so that you remember order of operations. Do this exponent first. Then do the 2 to the exponent next. And then you do multiplication last. Keep that in mind. Order of operations here. The second question says, then find the 10th term. So let's use it to find the 10th term. The 10th term will be when I plug in 10 in for N. 10 minus 1 power. 1/4 to the 2, or times 2 to the 9th power. This is definitely a calculator problem. I don't know if you want to do 2 times 2 times 2 times 2 times 2 9 times, or if you want to just use that exponent button. 1/4, there's a fraction button on your calculators. The exponent button is this X with a little box on this calculator. It makes a box up in your window. 2 to what power? I'm going to use 9. If you don't know how to do 10 minus 1, you could even take that and put 10 minus 1 if you wanted to. But for me, one less button is easier. And the calculator will take the 2 to the 9th and then divide it by 4. And it knows the order of operations, so it'll do that for you. If your calculator does not have this button, if you have another fancy calculator, sometimes it's a caret. It looks like this. That is raising it to a different power. That button means raised to the power of. Might be that one as well. So my answer is that the 10th term is 128. A of 10. A of 10 has a value of 128. Let me just circle that as my answer instead. Next, missing terms. When I taught Algebra 2, we did more than one geometric mean, meaning we put 2 gaps or 3 gaps in between 2 numbers, and we said, what would the geometric means be? In this worksheet, or these sets of worksheets, they only use 1 gap, so I'm only giving you the equation for 1 gap. If there were 2 gaps, you would have to change what goes right here. Whoa. You'd have to change what goes right here, which is like delta n. But since that's not there, since every single question only has 1 gap, we can just do the square root, which is totally fine. Okay? So I'm going to erase that. These can be positive or negative when there's 1 gap, because you'll see in a second. But we're going to do the right value divided by the left value and then square root it to find the common ratio. Find the missing term of each geometric sequence. So I chose number 14. It could be the geometric mean or its opposite. I'll show you what I mean. Since these are geometric, we're going to multiply by something and then multiply by that by something to get to 16. And so if you look at this, it's not a whole number, obviously. So here's how we're going to do it. We're going to take the right value divided by the left value, and we're going to square root it. When you square root the right value divided by the left value, it is the same thing as the square root of 16 over the square root of 9. What is the square root of 16? What's the square root of 9? That's your r. That's not the missing piece. This is what r is equal to, meaning 9 times 4 over 3 will give you the next number. What is 9 times 4 divided by 3? That's 36 divided by 3, which is 12. If you take that and you multiply it by 4/3, if you did this right, you get the last number. So that middle term is 12, because you're multiplying by 4 over 3. The only way to answer number 14 and the ones around it is to figure out what the r is and then multiply each thing by it. And the neat thing about it is if you multiply by 4/3 again, you can actually figure out if you did it correctly, because you'll get that last term, like 16. The last examples that I have for you, I'm not going to do all of them, but I wanted to highlight problems that I did. When I was working on the homework, I go, oh, I got to talk about this on 25. Oh, I got to talk about this on 26. Oh, let's do 27 together because it deals with my favorite topic, money. Money, money, money. Okay, so 25, I'm not going to do the whole thing, but I do want to say this about 25. This year, the population was 1.05 times last year's population. What I want you to do is I want you to think of this year as A of 2. Last year is going to be considered A of 1, or your first year's term. So when you're answering the question for 25, I don't want you to get bogged down. Okay, this year, is that our A of 1? Or last year, is that our A of 1? It's not very clear. Whoever wrote it wasn't clear enough, in my opinion. So I'm going to clarify it for you. This year is the second year. The first year that we counted was A of 1. This year, it's this much bigger. So now with our second year, we can compare it to the first year. Knowing that, you're going to be able to write the equation. Knowing that, you should be able to figure out the fourth year. That means 2 years from now. Make sense? That's all I want you to add. You're still going to answer these questions on your own. 26. You enlarge the dimension of a picture to 150% several times. After the first increase, the picture is 1 inch wide. This is your first value. This is your A of 1. A of 1, it's at 1 inch wide. It's going to change because you're going to increase it again, and you're going to increase it again. You're going to 150%. You've probably never done this before, but I've actually taken something to a copy machine and put enlarge by 150%, and then it makes it bigger. And you can do that and do it again and do it again. But of course, eventually then everything pixelates. It can only do what it can do. But this is not what you're going to use for R. You don't use 150 because that's a percentage. You always need to convert percentages into a rate. What is the rate when you're going at 150%? R equals. If you know, tell the person you're sitting next to, please. If you said 1.5, then you are exactly right. If you said 150 over 100, that is the same thing. I would recommend moving the decimal place 2 places before you get your rate. 1.5 is what I would use for R if I were you. If you said 3 over 2, same thing. I say that because you're going to be using that to make your equations and figure things out. Number 27, on the other hand, is a problem I want to do with you because this is how it's used in real life. The only thing in real life that doesn't make any sense is that they say that they hope to increase profit by 8% each year. Increasing something by 8% is a good goal, but how do you know if it's going to happen or not? Who knows? And for the average American, having something earn 8% interest is not easy to do. The stock market barely earns on average 7 to 8% per year if you're lucky, depending what's going on in the economy. Okay? A corporation earned a profit of $420,000 in its first year of operations. That's our A of 1. Over the next 10 years, the company's CEO hopes to increase the profit by 8% each year. If the CEO reaches her goal, what will the company's profit in its 7th year to the nearest dollar? So what we have to do is we have to figure out what it would be. This 8%, I hate to tell you, would only calculate how much interest on top of the $420,000 you would earn. So our rate isn't 8%. If I want to know what the actual rate is, I'm going to have to do 1 plus that 8%, or 1 plus 0.08. If I really want to know or do this calculation correctly, I have to do 1.08, and that is the same if you decide to buy a car someday and you do not have the money to do it. If you hear that there is it's a 1.9% APR, and you've heard that on a TV or a radio station, and they're offering you 3.9% financing for well-qualified buyers, they tell you the 3.9, but don't forget to add the 1 to it, because you have the amount of the car plus the interest to borrow the money to pay for the car. Keep that in mind as you're doing a 5-year loan or 6-year loan, because it makes a huge difference of how much you pay for the car, which is why you should buy used and you should pay in cash, period. That's Mr. Paramo's mathematical opinion for you. Now, if you don't believe in buying used cars, you've been sold. Oh, you only got to drive a nice fancy new car. You've been sold. You've made an opinion about new cars and used cars. Financially, it makes more sense to pay for something that has already lost its depreciation. Cars lose so much value, it is financially. If you ever want to talk about it, I got a big opinion about it. I'm just going to skip that right now. A1, 420,000. R, 1.08. Now let's go in and jump right into our formula. Our formula is this. A of 1, which is our initial amount, times by 1.08 to the n minus 1 power. In the first year, if I plugged in 1, I would get 420 grand. We want to know what it would be in its 7th year. So I plug in. So this is, we're going to plug in 7. You can make the decision whether you want to leave the 7 minus 1 or you can plug in 6. It doesn't matter. But this is where I go to the calculator, turn it on, 420,000, make sure I have the right number of zeros, times 1.08 to the 6th power, just because I can do 7 minus 1 in my head. And this amount should be more than the 420,000. Let's see what it comes out to be. 6. That's a bad number. 487.2. Going to the nearest penny is what I think. What does it say to round to here? To the nearest dollar. I thought we rounded to the nearest penny, but apparently we round to the nearest dollar. $660,487 is what we're going to round this to in the 7th year. Pretty interesting. That means they want to increase by $246,000. That's a lot of extra money. Which kind of goes to show you, your parents, let's just do one last tangent. Your parents a lot of times are paying for their houses, and they're lucky if their interest rate is 4% or 3.75%. That's not to the 6th power. If they have a 30-year loan, that's to the 30th power. So keep in mind, if your house is worth $420,000 someday, or if you live in a house that's around here, the median is like $500,000, and you have a 30-year loan, interest on a $500,000 loan means that house, if you're paying on a 30-year loan, will cost you somewhere in the neighborhood of $900,000. You pay $400,000 in interest for a 30-year loan. Which is why I say this is the most powerful mathematical thing you can use the rest of your life. You are 14, 15, 16 years old. And it's hard for you to understand that this is something that you should consider when you are 19, taking a student loan, buying your first car when you're 21. Who knows? Maybe your parents are going to buy it for you. Maybe you're going to buy it yourself. Maybe your parents don't have that kind of money. Who knows? This is the kind of math that people who are a whole lot smarter than you use all the time to get every single penny out of you. So be forewarned. Your high school mathematics teacher tried to warn you about interest and raising things to certain powers. Oh, it's only 3% interest. Yeah, take that to the 30th power for a 30-year loan. It's a lot of money. Car companies will try to get you to take a 5-year loan and, let's just put it out for 10 years because they can get more interest out of you because of it. That's my rant. There we go.